Okay, so now we're going to graph rational functions. We're going to go through 4 steps. We're going to find the horizontal or vertical asymptotes. We're going to find the x and the y-intercepts. We're going to find the point, if there happens to be one, where the graph crosses its horizontal asymptote. Now make a note, a graph can cross its horizontal asymptote, but it will never cross the vertical asymptote. All right, so step 4, we're going to graph, and we're going to first draw all of our asymptotes as dotted lines. Then we're going to plot the x and y-intercepts. We may need to plot a few extra points just to see the shape of our graph, and then we'll actually draw the graph. And we're going to double check for holes, and we'll see what I mean by that as we do a graph. All right, so let's graph this function. Let's take it through the steps. First, we're going to find the horizontal and vertical asymptotes. And remember, to find the vertical asymptote, oops, that's really large. Let's we set the bottom to 0. So I'm going to set the bottom to 0 and solve this. I'll add 5. And we get x equals 5. Now, remember though, we have the second step of checking this in the numerator. So 5 plus 2, well, that's 7. It's not 0, so that's okay. That actually is a vertical asymptote. Now, I'm going to erase this up top just so we can concentrate on our horizontal asymptote. So let's look at the degree of the numerator and the denominator. The top has a degree of 1. The bottom has a degree of 1. So what we do is we consider the coefficients in front, since these are the same. And our horizontal asymptote is y equals 1. That's our horizontal asymptote. And let me make that h look better. Horizontal asymptote. All right, now we've got our asymptotes. Let's go to step 2, finding the x and the y-intercepts. Let's remember, to find an x-intercept, we always put well, let's start with the y-intercept because it's easier. To find a y-intercept, we always put 0 in for x. So let's find our y-intercept by putting, well, I thought I changed it, a 0 in for x. So I'll have 0 plus 2 and 0 minus 5. And that gives us really negative 2/5. Now it helps when you get ready to plot this stuff to go ahead and write this as a point so that you don't accidentally make it your asymptote. All right, so there's our y-intercept. Now to get an x-intercept. Well, to get an x-intercept, we set y to 0, or we set the whole thing to 0. Well, let's set this whole thing to 0 for a minute. Well, now that looks hard to solve, but the truth is this. The only way we ever get a 0 out of a fraction is if the top of the fraction is 0. We're not allowed to have the bottom equal to 0. That's what leads to our vertical asymptote, and it's not really in the domain of the function. So really, finding the x-intercepts amounts to just setting the top to 0. All right, so let's set the top to 0 and let's solve that. So let's subtract 2. And I get that my x-intercept is at negative 2. So let's write that as a point. It's negative 2, y value 0. Okay, so we've got our asymptotes. We've got our x and y intercepts. Step 3 is to find the point, if there is one, where the graph crosses its horizontal asymptote. So what we want to do is, here's our horizontal asymptote, y equals 1. We want to set our function equal to 1. So out to the side, I'm going to take, and let me change colors for step 3. Let's change it to orange. I'm going to take x plus 2 over x minus 5, And I'm going to set it to the value of my horizontal asymptote 1. Now, we want to solve this equation. And let's remember from way back on exam 1, to solve any kind of fractional equation, we multiply by the denominator. All right, so let's multiply on both sides by x minus 5. So on the left, when we multiply by x minus 5, it cancels out. And we have x plus 2 equals x minus 5. All right, now let's get our x's together on one side and let's notice something happens. And then we get 2 equals negative 5 because our 2x's cancel out. This is a sign that there's no solution to this problem, and that means that it never crosses its own horizontal asymptote. So that's nice to know. So it never crosses it. And that's going to make it much easier to graph if it doesn't cross its asymptote. All right, so let's go to step 4. Let's draw our asymptotes as dotted lines and plot our x and y intercepts. And I'll come back to those steps here in a second, but I'm going to change colors. And again, I'll change colors for the graph. So, okay, so our asymptotes were at x equals 5 for the vertical asymptote. So I'm going to go to 5. I'm going to draw a dotted vertical line going through 5. There's my vertical asymptote. Now remember, it's not really part of the graph. It's just going to help us to draw our graph. And then let's go to our y, our horizontal asymptote, y equals 1. Let's draw a dotted horizontal line going through 1. Okay, now let's plot our x and our y-intercept. So our y-intercept is 0, negative 2/5. So we just sort of have to estimate where that is. Here's negative 1. Negative 2/5 is not quite halfway down, so we'll plot it right in here. We don't have to be perfect. It's just somewhere between 0 and negative 1. And then our x-intercept is negative 2, 0. Which is right here. Okay, now we need, let's go up here, to plot a few extra points as needed. All right, now here's how we decide what we need as far as extra points. A graph on either side of its vertical asymptote is going to do, let's suppose that this is my vertical asymptote, and this is my horizontal asymptote. On the left side of this dotted line, this dotted vertical line, my graph can do one of two things. It can go like this toward its two asymptotes, or it can go like this. One of those two, not both. And then on the right side of a vertical asymptote, it can either do this, or you can do this. All right, so what we've got to decide here is, let me change back to the blue color. What's it doing on the left? Well, we can see that on the left of its vertical asymptote, it can't be up here. It can't be shaped like this because these 2 points right here are below the asymptote, the horizontal asymptote. So it must be shaped like this. So what we do is we just draw it shaped like that. And I know I'm not drawing very perfectly. And it's headed toward its vertical asymptote. So notice out here it's headed toward the horizontal. Over here it's headed toward the vertical. All right, now the thing is we can't tell whether it's supposed to go like that, like this one here, or if it's supposed to go like that, over on this side over here. So we need to plot one additional point to see whether or not the point lands up here somewhere or lands below the horizontal asymptote down here somewhere. So let's notice 1, 2, 3, 4, 5. We could plot the x value of 6 and see where our y value lands. All right, so I'm going to take x equals 6. I'm going to put it back into my original function, f of 6, and see what I get. So 6 plus 2 over 6 minus 5 gives me 8 over 1, which is just 8. So we've got the point here, 6, 8. Let's plot that, 6, 8. Okay. So if I go over here, probably gonna have to draw this a little longer. I'm gonna kind of, oh, I didn't mean to do that, but that's okay. And let's make 8 tick marks here. So this is 1, 2, 3, 4, 5, 6, 7, 8. 6, 8 is really right about there. Okay, that means in order to go through that point, my graph on the right side can't be this shape because that's down here beneath the horizontal asymptote. It needs to take this shape, and we need to pick up this point as we draw that shape. So it's headed toward that horizontal asymptote. And then up here, if I draw this a little longer, it is headed eventually toward this. And of course, headed toward this down here. All right, so there's the graph of that rational function. And we'll go through a second example.